This is the first lesson of the new unit entitled Transformations. So a transformation by definition is the change of position, size, or shape of a figure. There's four types of transformations. It's a translation, which we'll talk about today. There's rotations, dilations, and reflections. In this example, we see these airplanes flying across the sky. This would be a good visual example of what a translation is. They're keeping the tip of the airplane and the wings in the same position, and all they're doing is going left and right, or maybe they go up and down, depending on your viewpoint of the airplanes. So a translation is going to be a transformation that moves each point the same distance, the same direction. So we're going to go up, down, left, and right, and each point is moved the same. Its movement can be described by a vector, which we'll talk about in words, or an arrow notation. And the shortcut is it's a slide. It's just if you had this eraser on the board and we did this to it, that would be a translation. We slid it over and up, to the right and up. But it still is pointing up in this case. All right, a couple of things to talk about before we get into specifics. The preimage is the original figure. So if we look down here, this would be the original figure in one type of example. The image is the new figure, and the image is going to have these apostrophe marks. And these apostrophe marks is what we call prime symbols. So this point A is the preimage, but the image is A prime. If this were to move twice, like translate, one and then maybe reflect, we're going to have double primes. And so that will be something we talk about in a future lesson. This term isometry means that when you do a transformation, the resulting shape is the same size. It's the exact same. This is actually really important to understand this concept. The only transformation in which it doesn't keep the original size is a dilation. And we'll talk about that specifically in the dilation lesson. Here's an example where we're given a point and we want to translate it left 2 and down 5. So left 2, down 5, we end up here. So the coordinate is going to be -5, -2. All right, so when we translate left and right, that's going to impact the x coordinate. So if we look here, -3, and if we go left 2, left is going to be a negative in translations. So -3 minus 2 would give us a -5, a -5. In this case, we had 7 and we went down 5, so down would be a negative number, so 7 minus 5 is 2. So by using the coordinate in the words, we can still get the correct value without a graph. Right? And like we just said a second ago, the y value is going to impact the up and down. All right, now we talked about in words. Here's an example of words. There's also an example of what's called vector, and vector is these arrow brackets, and then the distance moved left, right, and up and down. So the left side number is the distance horizontally, and the right number is the distance vertically. So in this case, this would be 3 left and 4 up. Down here, this would be 4 left and 5 down. This would be 2 right and 9 up. So we'll sometimes see this used in problems. Here's an example now in what's called arrow notation. And so one way we'll see arrow notation is in this form here. Okay? And so we start with an x and y coordinate, and we do something to it, and we get a resulting coordinate. So for example, in this case, we're going to translate 1 left and 7 up. So if we go 1 left, the x value will be subtracted 1 value. And we're going 7 up, so the y value will be added another 7 values to that. So this would be an example of arrow notation. So here, point M is the coordinate -8, -4. So if we subtract 1 from it, so -8 minus 1, we end up with -9. And then -4 plus 7 is going to be +3. And we're going to do the same thing with S and the same thing with U. So here are the coordinates for S and U, and then M prime, S prime, U prime. And so when we graph this, we end up with this triangle, MSU, going into this position here. Okay. The translation vector is going to be -1, 7. And if you notice in the arrow notation, the -1 goes here, and the vector value goes here. So this is really a shortcut of arrow notation. All right, so when we're using arrow notation, right, we always want to start with x and y and describe how the x value moves, and then how the y value moves. So in this case here, how do you know where to start from? We're starting from the values that do not have prime symbols. So in this case, these do not have primes. So we're starting here and going here. So in this case, we know we're gonna go to the right and we're gonna go down. To specifics, we have to count boxes. Again, when we count on graphs, we count boxes. So this, in words, is gonna be right 5 and then down 6. So if I go right 5 and down 6, I'm gonna end up here from M to M prime. In in arrow notation, we would write x comma y, and arrow, x plus 5, y minus 6. And then in vector form, it would just be positive 5 and minus 6 in the vector brackets. If we look at this example here, we're starting here on the right because there's no prime symbols. This is very important to understand that. Where do you start from? There's no primes here, that's where we start. So now we have to go left and up. So when we go left, we're gonna go left 5 and then up 2. In arrow notation, it would be x minus 5, y plus 2. And then in vector, it would be minus 5, positive 2.